Here in front of you is several, you can call these functions or equations. And I'm curious right now, if we were to graph these 8 functions or equations, which ones of these would make a straight line and which ones of these would curve? I'd actually like you right now to pause the video and think about this question. Which one of these would make a straight line if we went to graph them? Do you know the answer? Think about that right now. So today we're really going to focus on how to graph lines. And here's the standard definition of a linear function. You know that a function or an equation is linear if its graph makes a straight line. And here's the criteria. In a linear function, all of your variables are to the first power. So in other words, you can't have like an x squared or an x to the third or a y to the fourth. Okay, if any of those happen, then it will no longer be linear. You can, in a linear function, none of the variables will be in a radical sign. Okay, so you would never have like the square root of x in a linear function, or you would never have a variable in the denominator, which is the bottom of a fraction. So if you ever had like a 1 over x, that would make it also not linear. So back to kind of our original question then, which of these lines are linear? Well, I believe there's 4 of them. I think sometimes it's easier to look at which ones are not linear. So this equation has an x squared in it. It would not make a straight line. If you're curious, it would actually make a parabola, which we'll study later in this course. Here I have an x to the third, so this would not be linear. X to the third actually makes a kind of looks like a cursive n. It's called a cubic function. Okay, definitely not a straight line. F has the square root symbol, so f would not be linear. It actually makes the square root function, it actually makes kind of a half of a sideways parabola if you're curious. And then this last one, we have an x in the denominator of a fraction, so it also would not be linear. These, I don't know if you studied these, they make this really weird double curve called a hyperbola. But at any rate, this one, this one, this one, and this one, if we go to graph these, guaranteed they will make straight lines on a graph because they do hit all the criteria. So as we look at our first example, this is a line. It fits all the criteria of a line. Now in particular, this is a line that's said to be in standard form. This is the standard form of a line. And in the standard form of a line, I'll show you this definition real quick. A line is in standard form if it's in this order. If the x term comes first, added by the y term, and equal to a constant term. Now it can also be written like this, ax plus by equals c. And technically to be in standard form, this leadoff coefficient of x has to be a positive whole number. But the key thing is the order. If the x term comes first, followed by the y term, equal to a constant term, that's said to be in standard form. Well, that's exactly what we have here on example number 1. X term, y term, equal to a constant term. Now, different teachers will teach you different ways how to graph a line in standard form. Me personally, though, I have a technique that I'm very fond of. It's called finding the x and the y intercepts. I would encourage you, if you ever need to graph a line and it's in standard form, I would encourage you to start like this. Make an XY table where you have with only 2 rows. And in the first row, you put a 0 in the x column, and in the second row, you put a 0 in the y column. And then, just like we learned in our last lesson, what we're going to do now is we're going to complete this table. Did you know if you plug a 0 in for x, if we do 3 times 0 minus 4y equals 12, well, the beautiful thing about 0 is that anything times 0 is just 0. And so in essence, we can actually say that it causes this x term to just cancel out. I'm going to cross that 0 off like it's not even there. And then look how easy it is to solve for y. I can divide both sides by -4, y equals -3. I have successfully now found the first point of this graph, 0, -3. The first point of this line, I should say, 0, -3. And I'm going to go ahead and draw it on my graph. And this point has a special name. This point is where the line falls on the y-axis. This is called the y-intercept. Now likewise, in the second row, I'm going to use a 0, but this time I'm going to put a 0 in the y column. And I'll write this out. If we were to put a 0 in for y, anything times 0 is 0. So 4 times 0 is 0, which I'm just going to think of as nothing. I'm just going to say that y term has canceled out. There's nothing left. And now I can divide both sides by 3. I'm left with x is equal to 4. I have now found the second point of this line at 4, 0. Now, you'll notice this is the point where the line crosses the x-axis, and this also has a name. This is called the x-intercept. Now, here's the beautiful thing. If you know that your graph makes a straight line, all you actually need to graph it are 2 points. Okay, I'm going to get a straight edge here. Now, if all I had was 1 point of this line, it'd be impossible to know exactly which way that line goes, which way it bends, what direction it follows. But since I have 2 points, guaranteed that line's going to look exactly like this. I'm going to draw a line through the 2 points that I found, and that problem is complete. I've successfully graphed this function 3x minus 4y equals 12. So here are a couple lines for you to try on your own. Both of these are in standard form. The x term comes first, followed by the y term equal to a constant term. Go ahead and here in a second I'll have you press the pause button. Try to graph these on your own, and then I'll come back with the, when you hit unpause, I'll come back with the solutions. And a quick note, I'm going to put a link to some printable graph paper into this assignment. You can click on that link, and then as long as you have a printer, you'll be able to print that out and work on that graph paper. So go ahead and hit pause, try these on your own. And remember, before I give you the solution, you're going to start each of these. This is how we start. By graphing a line in standard form, we're going to start like this. And voila, here are your solutions. First graph has a y-intercept at -6. The x-intercept is at -4.8. Connect those two dots and we have a line that shows all of the solutions of that function. And the second graph had a y-intercept at -4, an x-intercept at +8. Connect those 2 points and this line shows all of the solutions to this function. So our first example looked at a line in standard form where the x came first, but our second example is going to now look at a line in what is called slope-intercept form, also sometimes called the y equals form, and that's because the y now comes first, and the y is all by itself. This equation literally starts off with a y equals, and then we can see that is a linear function. So let's look at the rule for slope-intercept form. So slope-intercept form, when a line is solved for y, the coefficient of x is called its slope. Here's what you can do. Whatever number, when a line is in this form, whatever number is in front of the x is called the coefficient of x. That is called the slope of the line. And then whatever your constant term is here at the end, that is called the constant term, that is called the y-intercept. Okay, so let's put these together and see how we can graph a line in slope-intercept form. So first we're going to identify what is the slope. Let me write this out, y equals mx plus b. The slope is the number in front of x, so our slope here is this fraction 3/4. Now we use the letter m to represent slope a lot of times in these problems. So the slope of this line is 3/4. I'm just going to write m equals 3/4. And then the y-intercept of this line is this constant term. Since it's a -5, I'm going to say the y-intercept is -5. Okay, now here's the steps of how to graph this. Step 1. Start by plotting the y-intercept which means the line is going to pass through the y-axis at -5. We're going to plot a point at 0, -5. Because of this -5 here, we're going to start with a point at 0, -5 right here. Okay, that's step number 1. Now step number 2, we're going to continue plotting points using the slope, and we're going to follow this little pattern called rise over run. You'll notice that our slope is 3/4. Well, once we've started with a point at the y-intercept, the slope tells us what pattern to follow. The 3 on the top is called the rise. This means we're going to, from our original y-intercepts, we're going to go up 3 points, and then the 4 is called our run. That means we're going to go over, in this case, since it's +4, we're going to go right 4 points. So from our original point at -5, we're going to count up 3, and then right 4, and we're going to draw a second point. And we're going to continue this pattern for as long as we can. We're going to go up 3, right 4. And since I kind of run out of room at that point, I'm going to stop right there. Now, you can also always reverse this direction as well. The opposite of up is down, and the opposite of right is left. So we're also allowed from our original point to go down 3 and left 4. And I think I can do it one more time. Down 3, left 4. And now I have all of these points I was able to plot. If I connect them, this is my solution. Problem solved. The graph of this line in slope-intercept form is given right here. Now a quick note about the slope here. You'll notice our slope was positive. This fraction 3/4 is positive. Positive slopes will always go uphill from left to right. And so we see that a positive slope does mean up to the right. Sometimes students will ask me, they'll say, hey, how can down and left also be considered a positive slope? When we go down to the left, should that really still be considered positive? And the answer is, it is still considered positive, and here's why. You know, when you go down 3, you can think of that as a -3. And when you go left 4, you can think of that as a -4. But think about this fraction for a second. If we had a fraction -3 over -4, my negatives would cancel out. That's still considered a positive fraction. So that's why when you go down to the left, a negative and a negative, that's still considered a positive slope. Positive slope will always go uphill from the left to the right. Now, I always really like graphing a line in the slope-intercept form because it's a very visual technique. You may have noticed on the last example, we never used a calculator. We never did a single calculation. We're able to simply look at this -4 and say, okay, that's my y-intercept. I'm going to start at -4 and then continue with a slope of 5. Now I'm going to have you finish this one on your own. Just letting you know, a lot of times we'll write our slope, even if our slope is a whole number, a lot of times we'll go ahead and just write it as a fraction over 1. So this slope of 5, a lot of times when we're graphing this way, we'll write it as 5 over 1. Go ahead and press pause, try this on your own. When you hit unpause, I'll give you the answer. And here's your solution to that problem. You'll notice this line starts at -4 on the y-axis and then follows a pattern of up 5, right 1, up 5, right 1. You could also reverse it and take it down 5, left 1. Now let's try another check problem. Go ahead and try this one on your own. At this time, go ahead and press pause, and when you unpause, I will give you the solution. Here is your solution to this check problem. You'll notice that this line starts with a y-intercept of +7. This means the point 0, 7. And then a quick note about negative slopes. This was our first problem that had a negative slope. The fraction is -3/4. A -3 means that you go down 3. But then notice with a fraction, if a fraction is negative, you only consider one of these numbers negative. The 3 is going to be considered negative, meaning down 3, but the 4 is still considered positive. So that would mean in this case right 4. This graph would go down 3, right 4 from its original y-intercept, down 3, right 4. So a negative slope will always go down from left to right. It's kind of downhill from left to right. Now, of course, you can always switch these as well. You can reverse both of these and go up 3, left 4, if you'd like to take it in the opposite direction. Now, here are two last kind of trickier examples with slope-intercept form. These are a little tricky. I'm throwing some curveballs at you. Give these two a shot. Go ahead and hit pause, and when you unpause, I will give you the solution. So here's your solutions. Now, you'll notice that this problem did not have a constant term. If you ever have a line in y equals form without a constant term, you're going to say that the y-intercept is equal to 0. And that line will always start at the origin. It will cross the y-axis at 0, 0. And then, of course, it has a slope of 4 over 1. Now, over here, you'll notice that this line has a constant term of 8, meaning it's going to start at 0, 8. But it does not have an x term. Here, you would say a line like this has a slope of 0. You could even say 0 over 1 if you want. And a slope of 0 just makes a horizontal line like this. The last thing to point out in this video is that you are allowed to transfer back and forth between the different forms. So here we have a line in standard form. And I would recommend, if you had to graph this, I would recommend simply to use this little technique you just learned. However, that being said, there is a way to rewrite this in slope-intercept form if you do like slope-intercept form better. What you would do is you'd start by subtracting the x term over to the right-hand side. Now you'll notice that 16 minus 4x, those are not like terms. They cannot be combined. So I just have to write them separately. And then, to solve for y here, I'm going to divide away this coefficient of 2. I'm going to divide away this 2 to make it disappear. Now, the thing is, students will ask a lot of times, hey, Mr. Klein, what do I divide by 2? Should I take the 16 divided by 2, or should I take the negative 4 divided by 2? And the answer is you actually have to do it to both. The 16 divided by 2 is 8. The minus 4 divided by 2 would be a negative 2. I'm going to write minus 2x. And then lastly, we'll kind of flip-flop the order here. We'll write the negative 2x first and the 8 last. This is how we can rewrite an equation from standard form into slope-intercept form. Now, letting you know, you could also go in the opposite direction if you wanted to. If you ever wanted to write a line from slope-intercept form to standard, you could just very simply, in this case, since it's a negative x term, in this case I would add the 2x over to the left-hand side, and I'd have a positive 2x. This y is positive, and I would rewrite it so that the x term came first, followed by the y term equal to the constant term. All right, so that's all I have for you. Best of luck on this assignment. As always, let me know if you need any help. Take care. Bye.